Hi everyone, my name is Jia Hui. My meeting number is 203737. Today I would like to present my mini project about fixed-wing aircraft. So today we will cover the flight performance analysis. Flight performance analysis can be divided into two parts, which are steady flight performance and also accelerated flight performance. Instead of steady flight performance, it has thrust requires maximum lift to drag coefficient ratios, thrust available at maximum velocity of the airplane, power required, high lift device, rate of climb, gliding flight, range and endurance. While inside the accelerated flight performance, it has level turn, the pull out and pull down maneuvers, energy concepts, accelerated rate of climb, takeoff performance, and also landing performance. The aircraft chosen is Airbus A319. Is a turbofan short to medium range, narrow body, commercial passenger, twin engine jet airliners manufactured by Airbus. The table shows some important specifications about Airbus A319. Thrust requires. The formula at our left-hand side is drag polar. The zero drag coefficient is about 0.015, while the K constant is around 0.05. So we use the formulas of lift coefficient, drag coefficient, and thrust requires to obtain the graph below. The first graph is thrust requires against flight velocity. We can see the minimum thrust requires is lower than 50,000 Newton, while the velocity at minimum thrust required is around 20 meters per second. The next graph is lift to drag ratios against flight velocity. The velocity for minimum thrust requires is around 230 meters per second. The next part is aerodynamic relation associated with maximum lift to drag coefficients to the power of 3/2 and also to the power of 1/2. After all the calculations, we see that the velocity at lift to drag coefficient to the power of 3/2 is lower than normal lift to drag coefficient, normal velocity at lift to drag coefficients, and also the velocity at lift to drag coefficient to the power of 1/2 is the highest. Next is thrust available and maximum velocity of the airplane. Thrust available curve for a low bypass ratio turbofan is essential constant with velocity at subsonic speed. The high speed intersection of maximum thrust available curve and the thrust available curve determines the maximum velocity of the airplane. So the maximum velocity of our airplane at long range cruising altitude is around 800 meters per second. The next is power required. The minimum power required for A319 is around 9,000 horsepower. So what is the high lift device for A319? A319 has full span leading edge straight. It also has continuous single slot trailing edge frame. Next is rate of climb. It shows the ability of our aircraft to fly out and over obstacles depends critically on the climbing characters. Rate of climb also equal to excess power divided by our weight of the airplane. The first graph shows the power available and power required versus flight velocity, while the second graph shows the rate of climb versus flight velocity. We can see that the maximum rate of climb is around 1,000 meters per second, while the flight velocity at this maximum rate of climb is around 450 meters per second. What is the gliding flight? Gliding is an unpowered flight. The airplane is flying such that the power required is larger than the power available. The minimum angle of the gliding flight of our aircraft is around 3 degrees. So the maximum range for our flight to glide is around 20 kilometers. So the velocity at this maximum range is about 230 meters per second. The rate of descent, sink rate, is the downward velocity of the airplane. The sink rate for the case of minimum right angles is about 12 meters per second, while the minimum sink rate is about 11 meters per second. So the value is super close. What is the range and endurance? Our maximum range is around 9,000 km, while our endurance is about 25 hours. The next part is accelerated flight. The first session we'll discuss is level turn. A level turn is one in which the curved flight is in a horizontal plane parallel to the plane of the ground. The altitude of the level turn remains constant. So our weight at level turn is equal to lift cos angles, while our centripetal force mv squared over r is equal to lift side angles. The minimum radius is about 900 meters, while the loop factor at this minimum radius is about 1.4. The flight velocity at this minimum radius is about 93 meters per second. Next is pull out and pull down maneuvers. At our left side is pull out maneuvers and right side is pull down maneuvers. From the figures, we can see the difference between pull out and pull down maneuvers. For pull out maneuvers, the centripetal force is equal to lift minus weight, while for pull down maneuvers, the centripetal force is equal to lift plus weight. Their radius also different. For pull out, the radius is around 2,600 meters, while for pull down, the radius is about 1,600 meters. Energy concepts accelerated rate of climbs. The total energy of an aircraft is the summation of potential energy and kinetic energy. So the specific energy height is about 15 km. Takeoff performance. From the figures, we can see that the total takeoff system are the summation of ground rolls and also airborne distance. Inside the ground rolls, it also can divide into many small segments. So our total takeoff distance is about 2,000 meters. Landing performance. Landing performance is actually similar to takeoff performance, but in reverse. So, same as previous, the total landing distance are the summation of three parts, which are approach distance, flare distance, and also ground rolls. So our total landing distance is around 2,000 meters. Conclusions. For steady flight performance, thrust equals to drag and lift equals to weight. The aerodynamic ratios are important for the calculation of power, range, and endurance. Range and endurance are important for aircraft performance. Besides that, the accelerator performance of A319 was analyzed. For example, minimum turn rate and minimum turn radius of level turn, the pull out and pull down maneuvers, and also accelerated energy of climb. Thank you. Thank you everyone. This is my presentation today. The details can refer my report. Thank you.